Hello UT and hello the world, I'm your host, Andrew Rosas. And when I was a kid, I was obsessed with two things: dinosaurs and buried treasure. And thanks to a cataclysmic event millions of years ago, those two things are one and the same. Now that I'm older, I'm still fascinated with fossils, but my light skin and tendency to burn has kept me out of the sun-baked excavation fields. And while I'd love to put the pale in paleontology, thankfully researchers at UT are doing the hard work for us. And that hard work is paid off with the once-in-a-lifetime discovery of fossil remains of an ostrich relative that lived in North America over 50 million years ago. UT paleontology professor Julia Clarke just co-published a study on these findings and sat down to talk with us here at The Hook. So, Professor, what's so significant about this paper?
What we talk about in the paper is specifically, we name a new species, Calixavis grandii. It's named for a colleague of mine who spent his entire career, over 30 years, studying fossil fish from the Green River Formation, which is the primary fossiliferous parts of this deposit are in Wyoming. And this is a really diverse environment. You can think of it as like akin in diversity to a tropical rainforest. So what we describe today is new insight from these incredibly preserved fossil birds with feathers and the whole skeleton, insight into some of the anatomy of early relatives of ostriches and emus and rheas, these big flightless birds like the skeleton behind me.
I was gonna warn you about the skeleton behind you, but it seems you're already friends. So why is the discovery of this preserved bird skeleton so significant?
Fossil birds are rare. So what we have is in this site in Wyoming, where our new species comes from, is what's called a Lagerstätte. And a Lagerstätte means fossil bonanza or fossil warehouse.
I'd like to take a second to plug our new sponsor, Fossil Warehouse. Buried birds, dirt cheap.
And this is a situation in the fossil record where we have exceptional preservation. What that means in this case is not only abundant skeletons of animals, fish and lizards and mammals and birds, but also preservation of some of their soft tissues, like feathers.
One of the key things about this discovery is that it ties species of flightless birds we know today with their genetic relatives that actually could fly. So how does this project work with other research in this area?
What we're doing is studying this group of birds, these weirdos that might tell us about this ancestor of living birds. But we're a joint team with collaborators at Harvard who are looking at whole genomes for these same species. So we're looking at their bony features, their soft tissue features, and all the living species, and we're looking at all of the fossil records. So the new species provides key insight into this project.
If I was trying to learn about these misunderstood birds, I'd probably start with their bad emo poetry. So how has your research helped to understand the relationship between all these species of birds?
Pretty much every combination of relationships had been proposed. So we haven't understood how these species are related to each other. And we haven't understood how many losses of flight, or how long ago did they lose flight in these different parts. So that's what our fossil speaks to. It adds new data on the anatomy of this key group of flighted paleognaths.
My thanks to Julia Clarke for her insight and research, and hopefully someday soon I'll see these fossils next to my favorites. T-Rex, Archaeopteryx, Thesaurus, because that would be fantastic. It'd be great. It'd be, I wish I had one of those, what's another word for a compilation of synonyms? Anyway, if you enjoyed this video, please share it with your friends and subscribe to our YouTube channel. As always, I'm your host, Andrew Rosas, reminding you to stay hooked.